Melatonin is the silent conductor of the body's nocturnal symphony, a hormone with a nightly mission to usher in the human need for sleep. It operates on the edge of consciousness, guiding the transition from the sensory-rich wakefulness to the mysterious world of dreams. Known chemically as N-acetyl-5-methoxytryptamine, melatonin is a hormone synthesized primarily in the pineal gland, a pea-sized organ nestled within the brain's two hemispheres. To comprehend melatonin's essence, imagine the hormone as the dimmer switch of a room's lighting. As night falls, melatonin production ramps up, gradually turning down the lights of wakefulness, signaling that it's time for the body to prepare for sleep. Conversely, as dawn approaches, melatonin levels wane, the lights brighten, and alertness returns. This process is as essential to our well-being as the darkness that befalls the sky is to the nocturnal blooming of certain flowers or the emergence of stars above. The annals of melatonin research trace back to its discovery in 1958 by Aaron B. Lerner and his colleagues at Yale University. They isolated the hormone while studying the factors that influence skin pigmentation, only to unearth a substance with far-reaching implications beyond its initial scope. Since then, melatonin has been the subject of a myriad of research endeavors, broadening the understanding of its role not only in sleep-wake cycles, but also in a host of other physiological processes. The journey of melatonin from a mere blip in the scientific radar to a key pharmaceutical agent reflects its evolving scientific and medical significance. Landmark studies have illuminated its circadian rhythm-in-training capabilities, leading to the exploration of melatonin's therapeutic potential in sleep disorders, jet lag, and shift work adaptation. Melatonin's importance transcends its role in sleep regulation. It serves as an antioxidant, modulating immune responses, and has been implicated in the protection against cellular damage caused by oxidative stress. The benefits of melatonin have made it a subject of interest, not just in sleep medicine, but also in the treatment of cancer. As some research suggests, it may have oncostatic properties. In the arena of sleep, its utility as a natural sleep aid has been widely embraced, offering an alternative to synthetic hypnotics for those grappling with sleep disturbances. Its ability to cue the body's internal clock makes it a significant player in the orchestration of the sleep-wake cycle, which is central to maintaining overall health and well-being. The scientific and cultural fabric of melatonin is as varied as it is intricate, woven through with different threads that represent the diversity of approaches to and beliefs about this enigmatic hormone. In the realm of science, melatonin is considered through a myriad of lenses: biological, psychological, and chemical. Researchers dive into its effects on circadian rhythms, explore its potential to ward off the oxidative stress related to chronic diseases, and scrutinize its implications for mental health. However, the scientific perspectives also spill over into the field of chronopharmacology, where timing the administration of treatments in alignment with the body's biological cycles can profoundly affect their efficacy. Culturally, melatonin has been embraced as a natural remedy for sleep disorders, gaining popularity for its perceived safety profile when compared to prescription sleep aids. It has woven itself into the fabric of societal norms, where the quest for optimal sleep is paramount in a world rife with digital distractions and round-the-clock engagement. Yet, within this tapestry lies a complexity of viewpoints. Some hail it as a panacea for various ailments, while others caution against its unchecked use, suggesting that more research is needed to fully understand its long-term effects. The challenges associated with melatonin are as multifaceted as its uses. For one, its role as a sleep aid is double-edged. While it can provide relief for some, it may lead to misperceptions and misuse by others who view it as a catch-all solution for sleep issues. Moreover, the widespread availability of melatonin supplements can lead to overuse or to the assumption that more is better, which is not always the case. The hormone's natural production is a finely tuned physiological process that can be disrupted by over-reliance on supplements, potentially leading to altered sleep patterns and other hormonal imbalances. Additionally, while melatonin is widely studied, questions remain about its pharmacokinetics and optimal dosing strategies. Variability in supplement potency and purity can create inconsistencies in consumer experiences, complicating its efficacy and safety profile. Discrepancies in regulation, particularly because melatonin is often sold as a dietary supplement and not as a medication, further contribute to these challenges. An exemplary case is the use of melatonin in managing sleep disorders in children with neurodevelopmental disorders such as autism. Here, melatonin has been a beacon of hope, with studies showing benefits in sleep latency and duration. However, the balance is delicate, as these populations may be more susceptible to side effects, necessitating careful dose management and monitoring by health professionals. In essence, the journey of melatonin from a simple sleep aid to a subject of complex debates and research illustrates the dynamic interplay between medicine, culture, and individual health needs. It stands as a testament to the need for continued research and dialogues to harness its benefits while navigating its challenges with informed precision. The intrigue surrounding melatonin extends into its less explored, almost mystic aspects, where its involvement in human physiology can be surprising and sometimes downright bewildering. For instance, consider melatonin's involvement in seasonal affective disorder, SAD, where the hormone's interplay with light therapy brings forth an elegant dance of biochemistry and photoperiods to alleviate symptoms of depression associated with the changing seasons. Then there is its relationship with the aging process, where melatonin levels have been observed to decrease with age, potentially implicating it in the sleep disturbances commonly experienced by the elderly and sparking discussions about its use as an anti-aging intervention. Melatonin stories also thread through the tapestry of cultural experiences. For instance, it emerges in the tales of jet-lagged travelers who use melatonin to resynchronize their internal clocks with new time zones. Such personal narratives not only serve to highlight the hormone's practical utility, but also hint at its broader cultural resonance as a marker of modernity's challenges to human biology. The potential of melatonin stretches into realms as diverse as gastroenterology, where its role in gut motility and its potential influence on the microbiota are opening new doors to understanding digestive health and diseases. Even more profound is the emerging evidence suggesting melatonin's neuroprotective roles, potentially offering therapeutic value in neurodegenerative conditions such as Alzheimer's disease. Here, melatonin is not just a hormone, but a biomedical frontier, a small molecule with implications that loom large on human health. Predictions for the future of melatonin research and applications are as promising as they are speculative. The expanding understanding of its antioxidative properties points to potential uses in combating a range of oxidative stress-linked conditions, from cardiovascular disease to chronic fatigue syndrome. Furthermore, melatonin's role in immune system modulation offers an exciting avenue for research, particularly in the context of inflammatory diseases and cancer therapy. As science delves deeper into the genetic and epigenetic mechanisms that regulate melatonin synthesis and signaling, personalized medicine could see melatonin-based therapies tailored to individual circadian rhythms. This could revolutionize the treatment of sleep disorders, making use of genetic biomarkers to predict responses to melatonin and optimize its therapeutic potential. The conclusion of our exploration of melatonin brings us to the realization that we stand on the precipice of many breakthroughs in understanding this hormone's full spectrum of action. Its multifaceted nature embodies the elegance of evolutionary biology and the intricacies of human health. As we continue to unravel the enigmas of melatonin, we are reminded of the symbiotic relationship between our environment and our internal biochemistry, a relationship that melatonin helps to articulate in its silent, nightly passage through our bloodstream. In acknowledging its power and complexity, we learn not only more about this hormone, but also about the broader span of life in which it is so intimately woven. With the dawning of new research, the story of melatonin is far from complete, but it is one that holds the promise of fascinating revelations for science and medicine in the years to come.